what the model what the model learns is each conv 2D layer sorry, applies filters to this spectrogram, looking for patterns just like how it would in an image. It learns edges, transitions, texture, and pitch changes, all of which relate to musical structure. From filter to feature, pooling layers compress the time and frequency shape to focus on the most important parts. Dense layers at the end transform all these learned patterns into predictions, whether a note was played or not in each time frame. So even though this model was made for vision, it works beautifully for music because sound, when visualized, becomes structure-rich data that CNNs excel at interpreting. This is a screenshot that I took from the Jupyter notebook. It's the result of CNN hyperparameter tuning. So once I had a working CNN architecture, the next step was to tune it to improve performance. This slide shows the results of 5 different model experiments where I varied some key hyperparameters. Each row is one experiment here with variations in filters, kernel size, dropout rates, learning rates. So just let me give a little bit introduction about these parameters in CNN. So filters is the number of convolution filters per layer. More filters means more pattern complexity for the CNN. Kernel size means how wide the filters are. So 3 by 3, 5 by 5. So these are the kernel sizes. Dropout rates control overfitting. Higher dropout drops more neurons. Dropout is the regularization technique, which is part of the classical ML technique, and it is called dropout for CNN architectures. It's used during training to prevent overfitting. If the dropout is set to 0.5 or 0.3, it determines the dropout rate of like 50% or drop 30% of the neurons randomly in that layer during each training batch. If it is 0, then it means no dropout, all neurons active every time. Learning rate determines how fast the model learns during training. I evaluated each model on 2 metrics: test accuracy and test loss. Test accuracy determines how many notes the model correctly predicted, and test loss determines the binary cross entropy loss, better for capturing true performance when predicting many notes at once. So as you can see from here, that accuracy is quite low overall. Which is expected because we are dealing with music and it's multi-level music prediction task where many frames are empty. When I say many frames are empty, I mean that I am trying to capture what notes are played at what time. So only like if the matrix contains all the notes, so only certain notes will be played at each time frame. So that's why it's a sparse matrix. Here in this particular screenshot, experiment 3 gave the best trade-off between complexity and test loss. So I used that architecture moving forward. This compares the MIDI note distribution between the true and the predicted MIDI. It's the comparison between the original MIDI notes used in real music and what the model predicted. The top one is the true distribution. It it gives us a natural widespread pattern across many pitches, typically, which is which is used in an expressive, rich music. In contrast, the predicted notes, which is the bottom graph, is much more concentrated. And as you can see that a few notes are repeated many times. It is like a learning shortcut for the model, as I can predict, favoring a few pitches, specific pitches, rather than understanding the full musical structure. So as you can tell from here that this is just the start of my journey. It is kind of a base model that I can take, and lot more work needs to be done to be able to predict MIDI notes correctly, or improving accuracy, I can say. So fixing this requires better training. So I need to put more training time into there. And I also think that I started with a complex music. I need to start with very simple music to train the model. It's just like training a child. Play a simple music and train that with the corresponding MIDI file associated. It can be training in different environments, like in a noisy environment versus it's in clean environment. All these things, I think it will help train the CNN better, and it can predict better. So model inference pipeline, it was deployed in Google Cloud. On the left, you can see the data source, which is the Kaggle. And I got the MP3 files and corresponding MIDI file sets from there. Cloud storage is all the data is stored in the Google Cloud Storage bucket. Audio files, training set, test set, models, all were stored here. So I took it like a central data lake for my project. Vertex AI on the right, we have Vertex AI, where the actual model was deployed, and it was trained and deployed over there from experimentation in Jupyter notebooks to the model registry to endpoint deployment. Cloud Functions is the middle layer. At the core is the serverless backend. So Cloud Functions is a serverless managed service of Google Cloud that takes an audio input and sends it to the model endpoint and returns the MIDI prediction output. I have the governance, which is controlled by IAM, handles the access control, identity and access management service of Google Cloud. And cloud logging helps with observability, what is going on as we are running jobs. This end-to-end setup shows how a creative AI use case, audio to notes, can be fully automated and served in a scalable way using GCP tools. Let me touch on the SVM model. I used a few classical ML models to see how it can contribute in this project. So one of the use cases I found is it can predict the most common note. So it is the reason I chose SVM. It is good at small sample and high dimensional tasks, easy to interpret and benchmark early performances. Label generation. So I created the labels by scanning each piano roll and the MIDI note, feature flattening, and then, the traditional ML steps, the scaling, the standardization of the data, normalizing features, dimensionality reduction. So I used PCA techniques to reduce feature space. for model efficiency that is needed. Model pipeline, combine steps using scikit-learn, Python package to wrap all of this into a reusable, reproducible training pipeline. Now the Gen AI capability is demonstrated, like what I did with the generative AI. Let me highlight how this project taps into multiple generative AI capabilities, not just model training, but also creative evaluation and orchestration. So audio understanding was done through generative AI. We started by turning raw audio into structured spectrograms. These were like the techniques that I did, that I explained to you. This is done without the help of generative AI. Then I extracted embeddings from the from the audio. So I think I used the clap model to extract the embeddings, which gives like compressed learning representations that can feed into the downstream models. I applied function callings. So I used the Vertex AI endpoint and GCP Cloud Functions to operationalize model predictions. So in other words, I am using AI endpoints in real time, just like agents do. The generative AI evaluation. So after predicting the notes using CNN, I bring in Gemini, a large language model, to describe the style and emotion behind the music. So it can say that what kind of music it was. And then bonus was the vector storage. The embeddings are stored in GCS. This opens the door for future experiments, such as searching for similar songs using vector similarity, a common use case in music recommendation engines. This is a response from the Google Cloud platform. So as you can see that it gives the outputs where it is once the prediction is done. So where the file is stored, where the embeddings are stored, and it gives the piano roll summary. This is the generative AI capability. It says the piano roll has 88 active notes, and out of 88 possible keys over a duration of 100 time steps with an average note density of 2.88 notes per time step. It generates audio caption, a dense tapestry of piano notes, a whirlwind of sound where every key finds its voice, a sonic exploration of the instrument's full range. And it gives the music mood. It says energetic. I can show you the like little bit to give a flavor. Like here I have, this is the Google Cloud platform where I have, where I did all the, all the work, the modeling, and so I used Vertex AI notebooks where I did all the modeling work. And this is the Google Cloud Run function, which is used for automation. So and this is the Google Cloud storage where I saved all the files. From the Cloud Run, I should be able to run the model. So I have it ready. The command is ready. So I'm feeding in one of the MP3 files here. I'm inputting one audio file, MP3, and I give the prompt, transcribe my audio file and tell me the most common note. Okay, what happened? I don't know. Is it expecting something else? Okay, I think it was missing the code. So let it run. So here, basically, the response that I will get is this screen, what it shows here. That is the response we are supposed to get. Okay, I got some error. Anyway, this is the problem with the live demo. I don't know what's wrong, but this is technically what I'm expecting to get as response. So as I am wrapping up my presentation, I want to spend 1 minute on the reflections and lessons from this journey. So the first of all, it's about starting in an unfamiliar territory. So coming from a background in text-based data, working with music felt completely new. Unlike labeled rows in a table, audio is continuous, layered, and hard to visualize, which made me initially overwhelmed. Finding a way in. So I began by doing focused research to understand how sound can be converted into music, into numerical formats like spectrograms and piano rolls. That gave me the foundation to start experimenting. Complexity of real music. The raw piano performance in the dataset were long, expressive, and nuanced. Uh, in hindsight, starting with simpler, shorter audio clips could have helped me build confidence before taking on complex compositions. Visualization gaps. One of the biggest challenges was seeing what was happening in the audio features, in the MIDI structure, in the model's predictions. So all of these have lack of visibility, I would say. Like I need to use libraries to see some web forms and see some how the MIDI file looks, but nothing can be easily seen in numerical representation. So lack of intuitive tools made debugging harder and progress slower at first. Future work to improve accuracy. So explore sequence modeling further. So music is inherently sequential. So RNNs or LSTMs might do better job understanding how notes evolve over time. This can help with better note prediction over longer audio stretches. Transfer learning. Just like we use pre-trained models for images, we can use pre-trained architectures like ResNet on spectrograms or other models trained on music datasets to give our model a better starting point. Audio embeddings and transformers, models like CLAP can convert audio to embeddings that capture tone, rhythm, and mood. We can then use transformers on these embeddings to predict MIDI with more context awareness. Better data engineering. Finally, just improving how we prepare the input, how to slice the audio, how to clean the MIDI files or post-process predictions can often lead to meaningful gains. So future enhancements for automation. Once a model is deployed, the real challenge begins. Keeping it accurate and aligned with real-world changes is the key. We plan to automate retraining, implement model monitoring, and build feedback loops into the system. This will help the models continuously improve, reduce technical debt, and potentially evolve toward reinforcement learning frameworks. Thank you. And this is an open source project. Please feel free to collaborate and contribute. I have the QR codes for a Medium article that I published like maybe a couple of weeks back, and the GitHub repository, which is a public repository. It's open to everyone to collaborate and contribute. So any questions?
Thank you so much, Monobina. That's a really innovative topic and it's a very interesting project. I'm sure we all have a lot to learn from this. And with that, I'll open up the Q&A session for you. One of the questions that I have for you is how do you see automatic music transcription being used in media or streaming platforms like Amazon Music, Apple Music, or even Netflix beyond just accessibility or titles?
So the question is, how do I see the transcription working for these music sources?
Yes, I mean, they do have subtitles and all that, but what are the applications for automatic music transcription for these companies like which is essentially media tech?
Yeah, so that's a great question. I think it doesn't exist currently, uh, if I am not wrong. So I think if uh, if this research can go further, that will be achieved eventually. Uh, it's about real-time music transcription. That's the use case this research tries to aim, but it is we have long way to go. So I think there are, the libraries that I used in this research, uh, they are not written by me. So there are basic libraries, but there is no one uh, button to press, which it can, you can give the song and it can give you the transcription. Yeah, like it can be a vocal or instruments, but yeah. So I think it doesn't exist, but if it can happen, then that is the end product we will get. That as we play real time music from, Apple Music or from YouTube or from any concerts, we will be able to visualize the MIDI notes in real time. So that is the dream, I have, that maybe it can be possible. Yeah.
Okay, thank you so much. So, next question is what evaluation methods can be used to assess the effectiveness of using Gen AI like Gemini for generating creative captions that describe the style or genre of the music?
So I think one of the important aspects of this research is to have a deep music understanding. So, uh, you know, you, you feed in a music, which, a lot of us can understand that the feel of the music, what the tone looks like. Then this process is outputting a MIDI file, which needs understanding of music. Um, so the large language model is essentially looking at the MIDI file and it is predicting the mood of the music. Um, so in order to, like when I fed in this particular song, which I played at the beginning of my presentation, it seemed to me a very rich song. It's like it seemed to me that it's a rich song with a lot of notes, and it has a vibe which is energetic, happy, uh, uh, music tone. So when I fed it into the generative AI, it gave that it represents an energetic tone, which I, as a normal person with not a lot of music understanding, it felt that, oh, that's correct. And it also gives an explanation that uses a lot of music keys, music notes, and it seems to be a vibrant, so it aligns with my music understanding. But in order to take this research and make it really happen, I think music experts and technology experts need to work together to bring in the outcome that we are looking for. I think you are on mute, Madhuram.
Oh, I'm sorry. So, thank you so much for your detailed explanation on those aspects. We have a couple of more questions for you in the chat, and just in the concern of time, we would like to proceed to the next speaker.
Thank you so much, Madhuram. And thanks everyone for listening in and giving me the opportunity to present my project over here.
Thank you so much. It's always great for WITS to have expert speakers like you that come up with really innovative projects. So, with this, we proceed to the next speaker of the day, Ojasvi Khanna. Ojasvi is a data scientist too at Xbox in Microsoft, where she develops machine learning models, causal discovery frameworks, and forecasting solutions to support Xbox's marketing and business teams. With 3 years of experience at Xbox, her insights and models have driven business growth and enhanced player engagement on PC Game Pass. She is passionate about mentorship and is an active mentor for women in data science at Microsoft and an official UC Berkeley data science mentor, giving back to her alma mater. Outside of work, she enjoys playing indie games, skiing in the winter, and hitting the tennis courts in the summer. Over to you, Ojasvi. We look forward to your workshop right now.
Thank you, Madhuram. Can everybody hear me okay?
Yeah.
Okay, awesome. I will start sharing my screen. Okay. Alrighty. So can everybody see my screen?
Yeah.
Okay, great. Thank you so much. My talk today will be about predictive analytics. I will jump into methods to model human behavior. And I will pivot away from this presentation in the middle to go towards a Google Colab notebook where I've written out some really cool code and we can go into it together and do a walkthrough. Just as an FYI, all this work is sort of very similar to the work that I do in my full-time job. It's very similar to work that lots of data scientists do. So in case you are preparing for interviews or if you are trying to see what data science looks like in the real world, I think this is a pretty great example. I have a few goals that I want to hit. The first is I want to leave everybody in this call with an understanding of the basic foundations of predictive analytics, mostly what it is, how it can be used, and future use cases. Second, I want to dive into different modeling techniques. This means what kinds of ML models can be used, when to use which one, and what kind of data best supports each model. And the last is I will walk you through a coding workshop, which is based on this very cool thing called user churn prediction. So in industry, churn means somebody leaving a subscription in the next month. This can also be applicable to an app. For example, if you are Netflix, you have a bunch of subscribers today in this month, and next month, some people will leave, and those are called churners. So these churners exist in all industries. They exist in subscription-based online industries. They also exist for your go-to, perhaps like a coffee shop, where a bunch of people are repeat customers, and some people come once and then never again. So those are churners. For this workshop, I made a synthetic data set. I'll be happy to share that synthetic data set at the end of the workshop. And also the Google Colab notebook will be up for sharing as well. Great. So when we think about analytics, we think about many different types. The first is descriptive, which is asking the question, what has happened in the past? An example of a descriptive analytic is monthly churn rate. Going back to my churn analogy, this whole presentation will be about churn. It's figuring out month to month what the number of churners look like, what the rate looks like. And then after that, we can jump into the second part, which is diagnostic, asking why is it happening? For example, why is churn rate higher in the month of February each year? Why is churn rate lower in the months of December and November each year? And then asking the question, what makes these users churn? Diagnostic analytics is a very interesting branch where you work a lot with the business people and also with researchers. And sometimes you go out in the field yourself and ask your users questions. Diagnostic analytics, when it comes to churn, is very important so that you know the correct path that you're going on and that you have good hypotheses for the data that you are working with. In my analogy of in my example of churn rate being lower in December and November, a normal question would be, well, those seem like they're holiday months, families are together, maybe people want to watch more TV together. That's why Netflix subscriptions increase. People don't want to leave. They have some really nice Hallmark movies coming out. So you just want to make the most of your subscription because you have friends and family over. And then we can go into predictive analytics, which is asking the question, what will happen? This is more future looking. You are sort of an oracle here. You are trying to predict what will happen in the future and try to answer the question, who will churn next? So this is a very interesting aspect of data science where it's sort of an art and a science together. And the reason why I say it's an art is because you need to know what kinds of users tend to churn more. For example, if you are a new Netflix subscriber, certain behaviors that you do might indicate that you will leave next month. And you might be doing these behaviors in the first hour or in the first day or sometimes in the first 1 week. And a part of being a data scientist is modeling all those different types of timelines to come up with the final answer of, I think this person will churn. Maybe you're playing, maybe you're watching too little, maybe you're not engaging enough with search, maybe you just watch one movie but only watch 10% of it, and then you go to the next movie, watch 5% of it, and so on and so forth. So it's very small behaviors, but it's a lot of data which has to be modeled. And the last part is prescriptive. So now that we have descriptive, diagnostic, and predictive, how do we combine them? So what should we do as a business? An example is offer discounts to likely churners. And you see this a lot in current subscriptions. Let's say you want to subscribe out of Hulu. Immediately they will ask you, hey, if you stay a little bit more, we'll make this month free for you. Or they'll say, they'll give you a bundled discount that you're paying just for Hulu, but you can also pay for sports in this money that you've already spent. So you'll get more benefits, more discounts, more watch time. So yeah, all of those are trying to answer the goal of how can we make people stay longer? How can we benefit from all the different data points that we collect for a user? Also in the middle, if you guys have any questions, just feel free to unmute and answer because I can't see the chat right now. Great. So yeah, a lot of talks in this conference have been about AI. So I wanted to just explain where predictive analytics falls in the grand scheme of things. Artificial intelligence is the bigger circle here, and a subpart of it is machine learning. A subpart of machine learning is deep learning, and then we have Gen AI, which is your ChatGPT, Gemini, generative models. And then all of them have very similar models that they work with, and they span across all these different, Venn diagrams. But machine learning specifically has, so the yellow subcircle here, that has many different parts inside of it. We have unsupervised learning, we have supervised learning, then we have reinforcement learning. For predictive analytics, we mostly work with supervised learning, like classification and regression. Supervised learning means that we give our model very concrete cases of when a user churns and cases for when a user stays. And we try to be as broad as possible. We try to incorporate all possible use cases so that our model is general. It can correctly identify behavior across many geographies, user groups, profile groups, and it can give us accurate answers. So yeah, supervised learning is, I would say, the easiest branch of machine learning compared to unsupervised and reinforcement learning. But that does not mean that all predictive analytics is only supervised. Sometimes we have to do customer segmentation, where we dive into unsupervised learning. Sometimes we have to make recommendations to our users that we are predicting on. So then we jump into unsupervised learning. And then a lot of time we have to use some kind of real-time decision making. And for that, we have to convert our supervised learning models into reinforcement-based learning models. So you really jump between all the three categories, but you always start from supervised learning. So in this workshop too, I will start from supervised learning. Yeah, just as a macro view, I wanted to show where the predictive analytics industry is trending, especially after the release of Gemini and OpenAI. So 2022 was before OpenAI was released. It was still sort of in stealth mode. They hadn't made anything public. We had lots of, so that's the dark blue bars. We had all these different things still then, like chatbots, sentiment analysis, object detection, image sentiment, segmentation, predictive analytics, forecasting, and so on and so forth. But in 2023, when OpenAI and Gemini were released, the focus trended towards LLMs, and now it's trending towards agents in 2024. But that just does not mean that the focus has been taken away from your traditional ML fields like predictive analytics. In fact, it stays pretty much the same. Predictive analytics being the highest percentage used because most companies use these models to some degree, and it's a use case which is very useful for small businesses as well as for large businesses. So if you are just starting out in the field of data science, learning predictive analytics is very, very helpful. It'll cover lots of bases, and it's used just so much. Great. So let's dive into the process of making a supervised churn model. So you start with pulling your data, and this includes, some SQL knowledge or maybe some Python knowledge, some Excel knowledge. You're making sure that your users have adequate representation through features. And then after you pull your data, you conduct some exploratory analysis. You try to make more features, or you try to reduce the features that you have to only those that are the most impactful. Maybe you make some visualizations, some correlations to see what is really happening with your users. And then you do some ML modeling, which includes training, testing, and validation. And then the last part is you use the ML model to segment your users, and then you deploy your whole stream using ML ops. This, I would say, is the ideal, gold standard that you're trying to work with and work towards. But real life is a lot more complicated. You pull your data and then you conduct some exploratory analysis, only to realize that maybe you need more features, or your features are wrongly pulling some data, or maybe your features are not very generalized. Maybe you pulled data only for one specific geography. And then you go back to pulling your data and conducting an exploratory analysis. And once you're final with that, you start your ML modeling, but your accuracy is not as high. Your precision recall curves don't have a curve on them. And then you go back to exploration. And sometimes you go back to pulling your data. And then, maybe multiple iterations of this, and you're finally happy with your model. You try segmentation, only to realize that the segmentation doesn't look accurate. It's not big enough. It's not large enough. Maybe your model is doing really well with training, test, validation, but the moment you put it out in the real world, it crashes, or it's taking too long to come up with an answer of will this person churn or not. So then you go back to step one of pulling data. That's just, the actual way how things work sometimes, and that's okay. But you just have to keep in mind that that is the actual use case, and it's completely normal to go through this process multiple times till the time you are, making progress. Cool. Now, there's a bunch of different ML modeling techniques. The most basic use case is logistic regression. It's used a lot in binary predictions, propensity scores, and it's very interpretable. A part of doing data science in the real world is making everything very understandable to a non-technical audience. You can use like the most complicated reinforcement learning, which has the best accuracy. But if it's a super black box system and people don't understand how it's working and it's not reproducible, then it's not great. Um, Another example is decision trees and random forests. These are my personal favorites. They're really great with categorical and binary data. You can also do some clustering, which is more unsupervised. Here you can see, maybe initially you can cluster your users to see what kinds of users you have. Maybe you have some low touch point users, some high touch point users, some users who only, subscribe in the holiday time frame, and some users who only subscribe when a really high production series like Bridgerton was released. So all of them will have different behaviors, different churn rates, and so modeling them separately would be a better use case than modeling them together. Because otherwise, you'll just have so many false positives and so many false negatives. You can also do time series work with ARIMA or LSTM, which is long, short-term memory models. And these work the best with sequential data. You have also lots of natural language processing techniques, and they work really well with sentiment data. Let's say you have comments or lots of like written words that need to be segmented. Maybe you get access to Bridgerton's screenwriting, and you can use that as a feature as well. So in that case, NLP techniques will be helpful. And then last was reinforcement learning. This is more real time. Most data scientists want to pivot to this at the end of their supervised learning techniques. So this is more advanced, and it's only once you have a supervised or unsupervised system running in place. Great. So now I'm going to shift from my presentation to my collab notebook. Can somebody tell me if they can see my collab notebook?
Not yet, Ojasvi.
Okay. Let me reshare my screen then. Uh, all right. Okay. Can you see my screen now?
Yes.
Okay, great. Yeah, as I mentioned before, you can you can have access to this notebook. I've written everything in it, but it's just a really great structure to follow if you are new to this area. I'll walk you through everything I've done, just because I'm kind of scared of coding in real time. Um, so as an input, I made some synthetic data which showcases churn. This is what this data looks like. I have a user ID. I have like 1,000 users. And then I gave them certain ages and genders and country where they're subscribing from. I also gave them watch hours per week, um, along with days since last sign on, number of profiles that they have, if they have a kids profile or not, if they've had any billing issues in the past 1 week, and then if they churned in the next month. So we have all these data at different granularity levels. I only used 10 columns for the sake of simplicity, but when I work with such data in industry, we have 1,000 columns. So, and these columns are, instead of watch hours per week, it can be something like watch hours in the last 1 hour, watch hours in the last 1 day, per week, per month, per year. So we can really change the time frames that we're looking at, and each different time frame is a new feature. Again, days since last login, we can really tweak that to so many different time frames. We can also change that up for like days since last login on your primary device. Maybe they watch Netflix on their TV as well as on their phone, as well as on their laptop. So we can check their device login data for all of those different platforms. We can check number of profiles, how active each profile is, really go in depth for all of these different categories. Um, and obviously look at, along with watch time, watch titles, if they watch TV series or movies, if they played any games, if they played any interactive TV. There's just so much that you can do with pulling data. But yeah, once you pull it, and if you have like 10,000 columns, then you will have to do some dimensionality reduction, or some correlation analysis to try to reduce that number to be more digestible, because you want your models to run in real time or as close to real time as possible and not be super expensive. And cost is a real factor with data science in the real world, which we sort of just glance over when we do data science for fun or in college. So moving forward, one reason I really like using collab notebooks is because they have view recommendation on plots. So you can just click one of them instead of making them one by one. You can just click them, and then it really reduces your time for EDA. So yeah, once you are happy with your data, you have to clean it and encode it. Now, cleaning really means in the real world, data is super noisy. You'll have lots of null values, and sometimes you have to make a zero for those null values. Sometimes you have to remove those null values completely, like remove a user which has too many null values. And sometimes you have to replace your null value with a different value, like -1. It really depends on your use case. So understanding your user group is extremely important before modeling them. Next that I do is I transform gender and country. This is not really required, but I'm just doing it here. So instead of female, male, it'll be 1 and 0. And for the different countries we have, it'll assign it a number for each country. Then go ahead and do some exploratory analysis where you look at the watch hours per user ID. Like certain users, because this is synthetically generated data, you won't really see a pattern. But it's very nice to see age groups and how they perform. Maybe your younger audience is watching a lot more than your older audience, and then you try to make more content for the older audience to engage them more. So your EDA as a data scientist in industry, yes, it's specific to a project, but it can be shared out a lot more times than you think. So after that, I wanted to do a correlation analysis where I wanted to see what is most correlated with churn. Obviously, churn is most correlated with itself. That's a full one value. But if they have billing issues, that's a really high correlation. Maybe, if you have billing issues, you are you could be fudging your numbers for your credit card. You could be using somebody else's credit card. Your credit card gets canceled, and that's why you don't come back with us. Maybe you remove your credit card details from the platform so that we can no longer bill you. Many things can happen in billing. But if they're having an issue, there's a high likelihood that they will churn the next month. Similarly, days since last login. This is all very as somebody who watches content online, I'm sure you can understand that if you don't log in as much, there's a high likelihood you're not making the most use out of your subscription. You're not using it to the fullest, you're not seeing value from it, and that's why you leave. So the moment we start seeing this behavior, we can assume that there's a high likelihood that they will churn next month. But as I said again, this can be used in so many more contexts. You can give this data to the content planning team and tell them, hey, these users are not engaging as much, they're not logging in as much. Maybe we should see why that's happening. So going to the bottom of it, what is not correlated with churn is watch hours per week. This really means that if you have high watch hours per week, you have low churn. And if you have low watch hours per week, you have high churn. So they're inversely correlated, and that's why it's negative. Now we come into the crux, the main meat of our presentation, which is ML modeling. You might have heard of train test split, but in industry, we do it slightly differently. We do train validation and then test. And this is very normal, 60-20-20. We train our model on 60% of the data, and then we test it or we validate it with the remaining 20%. And we can go back and forth, make the training better, so that it works better on the test set, and go back and forth a bunch of times. And then once we're happy with how our model's accuracy looks, we can use it on our validation set, which is data that the model has never seen before. That is how you generalize your model across multiple, geos and user groups. For my model, I used Light GBM, this one. Light GBM model is an industry standard. It's one of the best models you can use. I used a regression model instead of a classification model. I hyperparameter tuned it. Once again, this is synthetic data, so it's very small hyperparameter tuning. But in the real world, these parameters go really long and it takes a lot of time to tune it. But yeah, once I'm happy with how my model looks, I'll sort of generate probability scores. This is a number, it's not a binary number, it's any number between 0 and 1. And it is called a propensity score. This is the likelihood that the user will churn in the next month. And you can put it all in a precision recall curve. Usually, this precision recall curve does not look as pristine. This is synthetic data. It's very nicely made data. Usually, it's like, so if it's diagonal, it means diagonal across this graph. It means it's random. But because it's not diagonal, it's working really well. You can make a confusion matrix to check how your precision and recall work, to see how your false positives and false negatives work. And then at the end, you have to do some model checking, which is done here using a Shapley value. What this really shows is if you have high watch hours per week, so if you have low watch hours per week, you have a high likelihood of churning the next month. Similarly, if it's been a lot of days since you last signed in, you have a high likelihood of churning next month. If you have lots of billing issues, high likelihood of churning next month. Everything else was random, age, gender, kids, so don't worry about those. But yeah, this is like a very quick way of how you check if a user falls into a propensity score and what propensity score a user gets. And then based on these propensity scores, you can divide up your users into high, low, medium, very low buckets, and then market to them. You can market a certain campaign to low propensity users or high propensity users. An example is you come up with a new, engagement rewards plan, let's say, or you come up with a new notification plan, and you want to see if it has an impact on making people stay. So for that, project, maybe targeting users who have a high likelihood to churn, it's a pretty good idea so that you can see in real time how their propensity scores reduce or increase as they interact with, the notification system. So yeah, a very quick run through of um, generally how propensity scoring and predictive analytics works in the real world. Let me go back to my presentation to cover the last few steps. Yeah, so the coding walkthrough is available along with the synthetic data, so you can play with it a little bit more. But, ending, I wanted to talk about some ethical considerations, which is what users should be removed from your training and testing data, and who makes that decision. At the end of the day, it's your decision as a data scientist to make. What I would tell everybody is to remove users who are under 18. But age is something that a user shares with us, and can we really trust that user's age that they share? I know on Facebook, when I made my profile, I lied. So what's the likelihood that somebody else is telling the truth, right? Um, Again, what data features should be excluded versus included? Location, and to what, specification? We can really get your location to your zip code, but do we need that information? Um, are we happy with just your country and state, perhaps? Medical records. We can use the exact same churn, retention, engagement models, but train them separately for medical data. And in that case, how do we deal with medical records? Similarly, social security numbers. How do we deal with that? Um, I would say everything that is personally identifiable should be encoded so that it does not get into the wrong hands. And if possible, it should be shuffled, and then the personal identifiable information should be removed completely. At the end of the day, we are trying to predict human behavior and we're trying to play Oracle. And you have to remember that human behavior is tricky to model, extremely noisy, and sometimes it's not always predictable. You might be able to predict one segment of users very well, but not a different segment. Obviously, if you have lots of data for a user, they're very engaged, we will have more data for them. And by correlation, we will have better modeling for them uh, and higher scores for them. They will be less likely to churn. But that's not always the case for users who don't, uh, you know, stay with us that long, who don't have enough information with us. There's lots of ethical considerations to keep in mind as you model human behavior. But yeah, you should get the basics down, but always make sure that you're being ethical as a data scientist. Awesome. I think we have some minutes left, so I would love to hear any questions in the chat or unmute yourself and ask away.
Thank you so much, Ojasvi. That was a very insightful presentation, and we really liked the way you kind of stitched both the business impact and the notebook so that we know how a real world data scientist job looks like. And we do have few questions for you. My question to you is based on your tenure at Microsoft and the growth of the business that you have been able to make an impact on, I would like to know how do you collaborate with business and marketing teams when building and delivering your ML models? What's helped you to bridge your technical work with the stakeholder impact?
Absolutely. That's a very important question. And I think whatever industry you're in, I think you should always have a beginner mindset. So when I look into like collaboration with marketing team, I always have a beginner mindset. I ask them, hey, what do you do and how can I help you in it? So, learning what they do from scratch, like how they make their campaigns, how they figure out what colors to use in which campaign, what text to use in different campaigns. It's very helpful for me, and then I can make my models to benefit them. For example, certain users respond better to the color red than to the color green, and I can tell them that using some modeling techniques. And they can use that information and go back to their campaigns and make better campaigns. So you have to have a beginner's mindset with whatever team you're collaborating with, so that you have the most business impact. Yeah.
Sure. And in your work, did you come across marketing efforts that were kind of focused on a particular product feature that they were asking you, hey, can you help us with any product feature that we should be targeting our audience with? And how did you approach that situation if you have worked on?
Yeah, so I work with Xbox, and a lot of my work is with new games. So if a new game launches, we need to be able to like market that game well with the marketing team. And we always have some like cool little products coming out. And when I say product, it can mean like a small feature as well. Um, an example is for Valentine's Day, a feature that we worked on was when you log into Xbox, we will ask you, are you single or are you taken? And if you're single, we will give you games that are for single players. But if you're taken, we'll give you like co-op games you can play with a partner or with a friend or with multiple friends. Um, so to do that, we had to really look into the data better and see if this feature, if made possible, will even have any engagement, or will people just get angry and leave, and not play at all, which we don't obviously want to do. So for that, you had to dig into the data, try to see which users, are more warm to notifications, which users are like better suited for this, type of feature. And then we would work with the marketing team to give them like an estimate of, hey, it seems like about 2 million users are happy with this feature. Will be happy with the feature when you make it launch. And like 1 million maybe won't be that happy. And then we make a decision of, is it a green light or a red light? Yeah.
Thanks so much. And we have one more question for you. So, if someone is early in their data science career, and what skill and mindset helped you most in creating measurable impact? And how can these new job seekers or even people who are, changing their jobs into data science better align with business value early on? How did you navigate that early on in your career?
Yeah, it honestly was quite hard because working in an industry is very different from learning through boot camps or college classes or anything else. I would say go find a mentor, and it should be somebody who's been in the industry a little bit longer than you. My first mentor was sort of my age. She was like 2 years older than me. And I still like till date, have a mentorship relationship with her. Um, Go find a mentor and have a really personal relationship with everybody that you meet so that they can trust you and you can trust them to give you the correct information. So try to be as authentic as possible at work, obviously while being as professional. But yeah, mentorship, personal relationships work a long way. And then the last thing is always have the MVP mindset, which is minimal viable product. Just because you can make a neural network to make a predictive task does not mean you should start off with something super simple like logistic regression, something that just works, gives you like 70% accuracy, but it works, and that's good enough. And then you can always iterate afterwards. So you should really try to focus on creating impact by being fast, while having some space and room for improvement. So you can always come back and make it better.
Yeah, thank you so much, Ojasvi. We really appreciate taking time to be with us and present and share your journey with all of us.
Of course, thank you so much. This is such a great platform. As I said before, I love mentoring. I have some mentors in the WID space. If you guys ever want, I'm just a LinkedIn chat away. Thank you.
Thank you so much. So, with that, we will move on to our next speaker of the day. Our next speaker of the day is Karpagam, who's also one of our team members. She's a consultant at Doma Home with 8 years of experience in the tech industry, including 4 years in data engineering and analytics. She began her career at SAP, where she built a strong foundation in enterprise technology. Over the years, she has delivered end to end data pipelines and collaborated with several startups. Beyond her professional work, Karpagam is passionate about mentoring and teaching and is currently mentoring a few projects in collaboration with the Sunnyvale Council. So, with that, I'll pass it over to you, Karpagam.
Thank you, Madhuram. It's a great opportunity, and let me start by sharing my screen. Okay, can you see it?
Yeah.
Yeah. So today we are gonna talk about market basket analysis. It's such a wonderful topic, and I certainly believe everyone can relate to this topic because we all are a consumer in this era where there are like millions of transactions that is happening. So this is mostly about how to analyze the transaction data to get some transformative results, which can help the store owners, which can help the brands, which can also help the middle software providers. So how I started working was it was in 2020, and I got this project from a startup. What they were trying to do is they were trying to digitize Kirana stores. Because back in India, the project was mainly based off on Bangalore, and the Kirana stores are nothing but small stores. So how they are digitizing is when you go to the small stores, they don't have a process. So maybe they have a little bit of process, but it's not streamlined. So this is where they come in, they provide the software. For example, they were already launching a billing software for them, and I was working with them to get the product database in place. So I was building end-to-end data pipeline where I could add the features of product, I could add the barcodes, I could uh, do categorization like which brand they belong, the price, and etc. So after we are done with this billing software, we wanted to do something more. What can we offer to these small stores? How can we really help them? So this is where the market basket analysis came into place, and I was able to do a POC with them, and let's see. So the basket analysis is very simple. You have a bunch of transaction data, right? From the stores. So it's nothing but your bill that you carry. So why is the basket analysis so important? There were some classic tales that I would like to begin with. So a store or a bunch of stores observed that young dads buying diapers often grab beer. So what the stores did is this is a true tale. These were some of the classic stories behind it. So they kept the diapers and beers together, and the sales really soared. So there was also a cupcake catastrophe. So what happened is cupcake sales were suddenly dropping. Why was it dropping? So what happened is they went out of candles, and that's why the sales dropped. So you can understand the relationship, right? So it is so important that you have more products in your store for your stores to really make sales. There was also something like gamer survival kit where the people doing the video games, they wanted like a bundle product. Just a minute. Yeah. So there is also a fashion flop turnaround where they launched the scarves after the jacket season, and it was not going well. So even the seasonal trends and analysis were so important. So I do have a bunch of questions for the audience. So what is the weirdest combo you have ever bought? So just keep putting it in the chat. I'll just go over it at the end and we can discuss. So this is one of the questions for you. What is the weirdest combo you have ever bought together? All of these combos are very weird. Diapers is one class of thing and beer is separately another class. So at least the cupcake and candles we can relate to. So there are a lot of weird combos that we buy together. What is yours? And let's go ahead with market basket analysis. It's nothing but a data mining technique. It's to identify the patterns or association between items. So it's always about more than one item in the basket. So that's the core idea. If the customer buys item X, how likely are they to buy item Y? So if I were to buy bread, would I also buy jam or cheese or something? So that's the typical examples. We can always think of a lot of examples because there are like a lot of transactions that's going around in the whole world. So just for an interesting fact, over 30 trillion retail purchases are happening worldwide every year. That's like more than the combined GDP of US and China. It's like so many transactions are happening and we are also part of it. There's another question for you guys. What is one item you always forget to buy, but would grab if it showed up as a recommendation? I usually have a grocery list when I go to the grocery store, but I keep forgetting something my son asked me at the last time because it was not on the list. So there'll always be something that we forget to buy at the end of the day. Keep posting your answers. I can take a look at it at the end. So how does it work? So we do have the transaction data. So the company I was working with, they were already in business with a lot of small stores, and they have already launched the billing software. So we were able to get all the transaction data that is happening. So I started with doing a POC, and it had around 3 million rows, I believe, and I was taking a look at it, and I wanted to do some more analysis on top of it, which we are going to discuss with the later slides. So the main aim is to find a relationship between the products, and there are a lot of metrics like support, confidence, lift. We can talk about it at the later slides. So how is it used? When I was doing this POC, there was no clear intention that what product or what are we gonna offer, because the whole point was to decide what can we offer. So there are a bunch of things that can be used, right? We can see how to place products together, like in the case of diaper and beer, and we can also see cross-selling, like it usually happens, right? The cross-selling, when you go to McD, there's always a value pack, value combo, all the bundled offers that happens. And we can also do promotions. So in most of the stores, what happens is there will always be some product which are not moving. So they have two choices. Either they are gonna return the product back to the wholesaler or retailer that they bought, or they have to add in some promotion or bundling. And recommendation system, uh, they are going crazy nowadays. So we know we keep getting all those recommendations like that, like in Amazon. We end up even buying the things that we don't even need, or when we, like, I wanted to buy a pair of jeans, but then we end up buying all the other things except the jeans. So that's how it's going. And inventory planning. This is very important because the company I was working with, they got the billing software, they have the transaction data. Now they can do inventory planning, and this is something we always kept in mind. And I believe they did some amount of inventory planning software as well on the later stages after this POC. Another interesting fact on the way, Amazon processes around 66,000 orders per hour. That is like 1.5 million orders per day, and each with multiple items. That is what we are very interested in, right? So we want to get this pair of items which are brought together. So that's the whole point of doing the market basket analysis. So do you guys like frequently brought together suggestions, or does it help? it particularly helps my mom, I guess, the detergent and the scrubber that they come together with. So they are pretty popular. Okay, so let's talk about the data. I was saying, right, we had around 3 million rows of data, and it was from 3 stores, spanning across 3 months. So that's a POC I was working with, and I was doing the whole analysis in a Jupyter notebook because 3 million rows of transaction data is not much. So it's around 1 GB or something. It's not much. So what we did is I was doing this POC and I started with data cleaning. It's very important because the data was all around the place, and we need to do the basic data cleaning steps like dropping duplicates, quality check. We need to normalize the data, because there's always this unit of measure, right? We are seeing grams, liters. It's not very consistent when you come with data. So the next step is basically data analysis. And I could not insist how important it is before you start building your data. Before this project, I was working with an even bigger company, and the client was back in London. He was one of the biggest ads provider, and we were dealing with like TBs of data. I was asked to build a model, but then I ended up building a data quality pipeline end to end. Before building the model, and I cannot tell you how much it helped. The client was buying data from 2 providers, and one provider's the quality of data from that provider is very bad. So they were able to renegotiate, get the pricing down, and uh, it's a huge impact for the client. Like I was specifically thanked for it. So I cannot I cannot insist how important that you stare at your data for at least 2 to 3 days if it's small, and if it's large, like 1 TB, it takes a while for you to digest the data. Unless and until you are the domain expert, which we may not be for all the problems that we face. So another interesting fact is that Walmart once found that the sales of Pop-Tart surged before Hurricane. I have no idea why, but yeah, this was one of the phenomena. So this happens, right? If you go shopping for one thing, we end up buying 5 things. We keep posting them in the chat, like what were there, how was your shopping experience? It's a great way to chat with all of your other members as well. You can keep commenting. You can this is like a great conversation starter because we all are part of this consumer segment, and we can all talk about it and relate it in a way. Uh, so our data analysis journey started. The first thing was always the purchase distribution. So what is purchase distribution? Like, what are we trying to understand? We have these baskets. We are just gonna segregate the baskets into based on their items. So does a basket have 1 item or 2 item or 3 item or 4 item? How many items does it have? And that's what we start with always. So it gives us the overall purchasing behavior. Even for the stores, this is like extremely important, and this information can guide to the further analysis of the data. So that's where we start with. So are the baskets small or are the baskets large? So that we know what we are up against. So we see single and multiple items. The we are more interested with the multiple items. We are not very interested with the single items because we are trying to look at the association rules and the rules between the items. So we are going to check the single items and multiple items, and of course, we like you would have predicted, the multiple items are always big. Not many people go with single items. So we will concentrate with the multiple items on the further slides. We will see the association rules. We'll understand the customer behavior. So this will try to tell us whether the customer did a quick grab and go, or whether they did a planned shopping trip. So let me know. Another question for you. Are the product suggestions getting smarter or creepier on your online shopping? Let me know. So another important metrics is consequent and subsequent. Um, now that we are concentrating on multiple basket or the basket containing multiple items, we are gonna name an item as consequent and another item as subsequent. So consequent item is generally the first item, or it's called the anchor item. We're gonna take this item, we are gonna see what are the other items that are brought together with this item. So we're going to name them as subsequent item. For example, in this case study, I was doing a case study about the milk and what were the other, especially the brand Amul, and what were the other items that were brought together with Amul. So with Amul milk, people used to buy the full cream, they used to buy a different quantity, they used to buy eggs, and even a different brand of milk. So this is where we start analyzing more deeper into it. So we have created a pair, we call them subsequent and consequent, and we go ahead to find different metrics about them. So this is the basic foundation of the market basket analysis to see how often things are purchased together, so that we can go and discuss more about the association rules. So in my case, as I told you, the target product was the Amul milk. So you can also create a different type of chart, like pie chart or something, and see how much baskets, the percentage of baskets that had both the products together. That's the co-purchased item. We can count the frequency. This can help. This can help to understand the product relationship and target promotions, or even the stores to place the items together. That's what we want, right? We were trying to help these small stores to boost the sales. Another interesting fact: Target predicted a teen's pregnancy before her father knew, using the purchasing pattern. How crazy is that, right? Okay, let's talk about the key metrics. Key metrics is everything in MBA. So if you are discussing about market basket analysis, these are the three things you would want to know, and these are basics of probability and statistics, and these are not very complicated. So we have support, confidence, and lift. These are the basic three metrics that is very important, and that is very well talked around the market basket analysis. So what is support? Support is nothing but the proportion of transaction containing both the items. So if you're going to talk about the store, a specific store, you're going to see the proportion of transaction that contain both the items. For example, there are like 100 transactions that happened and that had both bread and butter. For example, 5 of these baskets have bread and butter, then support is 5%. It's nothing but probability of A union B, that's all. A intersection B, sorry. Another thing is confidence. Confidence is likelihood of buying item B given item A. We have done this before in school, right? So for example, if someone buys diaper, there was a high probability they also bought beer, right? So that's what we told in the first example. So that is what the confidence will give us. Confidence will tell us whether it's a high probability or not. So it's just like the how the name suggests. Lift is another very important metrics in market basket analysis, and lift basically tells us whether they are associated or not. So in probability, there are always two events, right? So in left, the one event is B, when the B is purchased when A is purchased. For example, when a diaper is purchased, the B are also purchased. And we are going to compare it against B being bought independently. How many people just buy beer, or how many people just buy diapers? So that it's basically the likelihood of both of these events. This will tell us whether they are positively associated or not. If lift is more than 1, then there is a positive association. So the chance of buying beer dramatically increased when the diapers were also in cart. So we will know the correlation between them. And this is particularly important, and we will also talk about a machine learning algorithm which implements all of this stuff. Let me know another question for you guys. Have you ever bought something only because it was near the checkout? I generally do that. There is this mouth freshener or something, a mint, that is usually placed in the Target, right? Or Target or Trader Joe or some whatever store you go to. I usually grab it just because it's near it's near the checkout area. Okay. Let's talk about the premium basket analysis and brand insights. These are very important. I wouldn't say this is important, especially for the store owners, but this is very important. We were in the or my client were the middleman software providers, right? So they can talk with the store owners. They can even go to the brand as well. So they can offer to the brand. So the brand, they will definitely know the sales, their monthly sales, and see the volume that they are selling, but they will not know how it compares against all the other brands. If they are very popular, they would definitely know they are very popular, but they would not know the analysis between different brands because that data is from either the billing software provider or the store owners. So in case of brand, we take a category. For example, if we take a milk category, there'll be like different brands, right? In my case, since I was working in India, there were Amul, Mother Dairy, Airy, Gokul, and all those things. So what we're gonna do is we're gonna calculate the RPI, which is Relative Price Index. The calculation might vary, but it's very simple. If you put it in math, it's very simple. So we are just gonna take the average price. We're gonna see if they fall. If they are in the average, we call them popular. If they are less than the average, we call them mass product. It's very cheap and affordable, where everyone can buy. And otherwise, it's the premium brand. So this is very important so that we know. We can categorize the brand based on the price that they have given, and we can compare how it's being moved, how the customer are purchasing this or their behavior pattern. So once we do this analysis, we can even go to the brand. We can talk about the pricing strategy. We can talk about the targeted marketing. For example, the popular brands may be the premium brands may be very popular among a society or where there are a lot of skyscrapers and where it's more developed, and the mass products may be popular in some other places. So they can always provide targeted marketing for that. And another thing which we can also see is the SKU, which is stock keeping unit. Even in something simple like milk, and if we take a brand like Amul, there are different variants of stock keeping units, which are like whether it's 1 liter or half liter or like depending on the sizes, and these might be selling in a different range. That is also something. So talking about the premium brands, so one of the general things that this premium brands do is they will bundle this luxury item with an everyday item. So that'll help to boost the sales. For example, a high-end headphone sold better when promoted with everyday work from home items like chairs. So that is also there. And the next thing is buyer persona. Buyer persona is nothing but how much are the customers willing to spend. It's just their spending habits. If you go to the grocery stores, whether it is like $200 or $300, what is it? So if you are very interested in one specific item, we are gonna how we are gonna calculate is we are gonna take the sale price of that item with net amount of the basket. What is the basket total basket value? A high percentage indicates that this is a significant part, you came here for it, or the low percentage indicates that it's just an add-on or minor component. Why is it important? It'll give us the key value pair and the customer segmentation, whether how much are they willing to buy, what is their relationship, how are they relating with this item, and if you want, you can do the promotion as well. If some items are not moving in the store, you can do that promotion. So an interesting fact is customer buying premium pet food are 2x more likely to buy pet accessories, suggesting strong emotional or care-driven bundling. It's something. It's the care-driven bundling is like an age-old strategy. Even not only for pets, even if we have kids and stuff like that, I think parents can relate to it. Okay, the next topic of analysis is unit of measure. So we have talked about unit of measure, right? There might be gram, liter, pieces. We are gonna try to group them and see how much, what is the distribution, or how many baskets have what, and all of these studies. It's basically for the inventory management. I have seen it mainly for inventory management. So how it happens is these small stores are not going to talk directly with the FMCG. So the FMCG's distribution goes something like, you go to the wholesaler or retailer, you push a product, and they are the one who's going to push the product to your stores. So that's how it generally happens. If the product is not moving, some of the very big FMCG will take it back. But in case of milk and butter and the things that go bad very easily, like vegetables, they are not going to take it back. So at the end of the day, it's going to fall on top of the store provider. It also tells us the cross-sell strength. So what it means is, so unit of measure is grams, right? There are a lot of trial packets of shampoo, even detergent, and all those things that get sold. So if the customer were to buy very less quantity, for example, if the customer were to buy trial packet, it generally means they are trying it out and they are not loyal. So if you're gonna buy in bulk at bulk amounts, you are very loyal to that brand. So you can also check the loyalty of the brand in that way. So this was the sales distribution was very important because the company I was working with was directly talking with the small stores. They're literally going to the stores and talking with them. So the sales was very important to them. So how much sales are they making? How much product are they able to move? How much customers do they get? How much transactions does it happen? What is their regional preferences? What about the holidays, and what about the time around the festivals and all those things? So this was very crucial for the inventory management, because they ended up doing inventory management at the end, and sales distribution was one of the important things that they wanted. Along with the sales distribution, they go along with the top selling items. How we are going to do that is very simple. We're going to take all the categories and we are going to get the top selling items across different transactions, so that we know the category distribution. So we can get these A listeners. Basically means what is the most popular items and categories, and we can identify trends around it, so that we know what we have to stock and how much is it moving, and all those kind of things. So another question for you guys: when buying shampoo, do you stick with the same brand or switch based on scent, size, or price? My husband keeps switching shampoos. I don't know why. I just stick with one shampoo which works for me. Tell me in the comments. Another thing is bulk purchase analysis. It's nothing but how much quantity are you able to move. So we always get this promotion, right? Buy 2 items, get 1 item free. So it could happen in 2 ways. because they really want to sell a bundled offer or the product is not moving. And sometimes some variants of the product will not be moving at all. For example, if you take the flavored yogurt, the bundled product will have blueberry, strawberry, and sometimes peach apple. My son doesn't like the peach and apple, but I always get the bundled product because there'll be like a lot of strawberries and blueberries, which he loves. And I can give the other ones to my husband. So it happens, right? So that is the bulk purchase analysis. It's mainly done to see how much can we bundle. Can we bundle 6 flavors together, or should we bundle 2 items together? That is what decides. So it's initially done like this. This is a violin plot. So the fatter section is the number of items that is moving. In case of milk, maybe 10 packets. So in case of bread, it is more fatter, right? So they bundle. It can bundle I haven't put the uh, quantity here, but it can be bundled more. So the more the fatter section, the more items you can bundle on that time. So that's the amount of sales that has happened. We have talked, right? So buy 2 store brand cereal, get 1 free. Sometimes these FMCG brands, they deploy or they try to sell different variants to see which will hit the market. So they have to be on top of the game, because it's like a really cutthroat business where you have a lot of variants and a lot of people. So if you take shampoo, like 1,000 shampoos, 1,000 brands of shampoos here in US right now. So, and that too, we are competing against all other different countries as well. And the next thing is discount. So the bundle, these bulk purchase analysis and discounts, they can also be used to move products which are not sold in like a really long time. It usually happens, right? So for example, if the Nike stores, they change the products based on the seasons. So if there are a lot of products or shoes and all the retail stuffs are not getting sold in one season, they'll put up a discount at the end of the season just to move the products out of the store. So this generally happens, and I do believe people really like discounts, or I like discounts. So you can take the bar chart, and this is nothing but how much, if the discount is put in place, how much are we getting sold. For example, if you take the besan or sugar in this chart, it's sold more when there is a discount. So we can see how the consumer are reacting to the discount. If it's moving more, they genuinely feel that should be priced less. So we can also take it to the brand to say that you guys should genuinely reduce the margin. So so in case of brands, instead of changing the price, they'll play with the margin. My father was in sales for like around 40 years, and I know how they play with margin. Even a 1 cent could make millions of dollars in difference for the actual FMCG brand. So we can know the profitability, that's what we talked about. We can know the customer sensitivity to price. If more things are sold when there is a discount, the consumer generally feels that it should be priceless, right? So, and also the promotion effectiveness. So tell me what's more tempting for you. It's a 20% discount of a specific item, or a bundled offer, like in McDonald's or something. Buy chips and get sort of free, 50% off. So which entice you more? Another distribution is net amount analysis. It's nothing but the spending distribution. So you just filter all the transaction or item where the saving was applied. So we were talking about the discount. The next genuine thing that happens is the net amount analysis. So we are just going to compare the sales and see how it affects. It's very similar to the discount analysis. And it, okay. So it's just to see the impact of discount and optimize the strategies around it. Let me know, do you ever spend more when you shop in store versus online? It's for me, it's always shop in store because you don't keep calculating the total, right? When it's online, you always know the total, so you can delete the items even after you put in the cart. Let me know your thoughts. And we talked about the anchor product, right? It's nothing but the most popular product. So what happens is the anchor products are basically they plan this, they place it in a place where they can sell the items around it. So the anchor product is particularly helpful. Have you seen the stores selling their own items? So Walmart has its own products, Safeway has their own products, even the Indian stores have their own products that they sell their own brand of flour and sugar and everything. So they place this anchor product, which is the most popular product. They keep their product next to them and they put like it's 20% off and make it very cheap. And myself or other consumers end up taking the store's brand instead. So this is something that they purposefully do. We can keep the anchor product to make the other products buy. So the anchor products end up being the loss leaders because they are not getting sold, but the products around them are getting sold. Another thing is you can do delivery on top of it. There are always these things, right? Even in Amazon or other shopping cart, buy $35 more, get a free shipping. So we can also do some analysis around delivery service and see how the purchasing pattern are. So it is quite positive with respect to delivery. There'll always be a larger order. You can definitely see that the orders are above 100 or 150 or something like that. There are also another variants, the brand sales and product variants. It's very particular for the brands. We do have some more analysis like price analysis, product analysis, time-based analysis over the time, how are the sales going, the seasonal analysis and the trends. I'm just gonna conclude by talking about this algorithm. This is one of the very basic algorithm, a priori algorithm, since I was doing a POC and wasn't that big of a data. I chose a priori algorithm, and we talked about the support confidence lift, and that's what this algorithm does. So it sees a support. We just have to give the minimum support threshold, and anything less than the minimum support threshold, it's gonna ignore, and it just cancels the noise. This is like a really very interesting question. Can you guess the number one cross-sold item in the grocery store? Cross-sold item is nothing but an item which you see in all the baskets. It doesn't matter whether they are kids or whether they are old people or the middle-aged people, anybody. Like, shoot your answers. I'm gonna tell you the answer at the end. And a priori algorithm, it's so we are talking about the association rules between two products, and there are like lots of combination. So a shopping cart would at least contain like 35 to 150 items, and there are like even for 100 items there are around 1.26 billion combination. It's insane to do this by hand or even take two things at a time. So that's where the a priori algorithm comes in place. It's smart because it just eliminates a lot of things based on the minimum threshold that we give. And we were talking about the association rule, and that's what it provides. Instead of calculating the support confidence lift and everything by ourselves, which we can do, this machine learning algorithm is gonna calculate it for you and give you the association so that you can say you can do the recommendation like what happens in Amazon shopping cart. There are some limitations. It's a very basic algorithm to start with. It's not very complicated, but if the data set is very big, it's gonna be really complex. We are gonna do multiple scans. We are gonna ignore the quantity and position, doesn't do that. And also we need to do the manual threshold. There are other popular algorithms like FP growth, ACLAT, machine learning based recommenders. You must have heard collaborative filtering and deep learning. These are the things that is used in Netflix, Amazon Prime, and stuff like that. We always get this recommendation, right? To watch the other movies. Since you have watched it and since you have given it like, people, you can also watch the other movies. So that is actually from collaborative filtering. So over 70% of Netflix views comes from recommendation algorithm. And I'm gonna end it. Just give me a minute, Madhuram. Sorry about it. So there are a lot of application about MBA. I don't need to say it. Again, we talked about the product placement, cross-selling, personalized recommendation, inventory management. It can even be used in fraud detection and healthcare and insurance. Thank you so much for having me. If there are any questions, you can ask.
So much, Karpagam, for a really thorough presentation with lots of metrics. I'm sure anyone who wants to do a market basket analysis would find the session very helpful to refer back. And with just concern for time, I would like
Yeah,
to answer the questions in the chat if you can.
yes, sure. I can do that.
Thank you.
Thank you, Madhuram.
And with that, I'll pass on to Nee to introduce our next speaker.
Hello, everyone. So our next speaker is Priyanaka Saraswat. She is a senior analyst at Latent View Analytics, where she leverages advanced analytics and data science to drive growth for the marketing team at YouTube Shorts. She specializes in building scalable data solutions, optimizing marketing campaigns, and extracting actionable insights to enhance user engagement. With a master's in business analytics from the University of Minnesota, Twin Cities, Priyanka has worked across industries, including energy, aviation, technology, applying predictive modeling, causal analysis, and AI-driven automation to solve complex business problems. Her work includes automating marketing asset analysis with Gen AI, designing A/B testing frameworks, and developing user segmentation strategies to improve campaign performance. Passionate about bridging the gap between data science and business strategy, she is committed to using data-driven solutions to fuel innovation and decision-making.
Thank you for such a warm introduction. Let me quickly share my screen. Hi everyone, thank you for joining. And my presentation today is around understanding how AI can empower our existing data science projects. And I believe that all of us must have asked this question in some time or the other in this ever evolving world of AI, whether or not ChatGPT will replace us. I think the better question to ask is who actually built the ChatGPT? I know that we are at a tipping point where we have a lot of data, we have faster cycles, and we have even higher business expectations. So we should be understanding how we can build on top of our existing data science skills and add AI tools in our skill set so that we can use AI as a co-pilot, as a brainstorm peer, and steer it for our analysis. So taking forward my presentation, I will be adding on a bunch of tools to the list that we can build on to our existing data science skill set and use for our analysis. So let's go to understand what exactly we have been doing for so many years in the existing data science workflow. We define a problem statement, then we collect data, we perform data cleaning and EDA. We spend a lot of time on EDA, understanding outliers, getting and understanding the null values, how to replace them. Then we also do feature engineering, and then we try out. We never stop at just building one model. We try out a bunch of models, and then we evaluate and deliver the results in form of a dashboard or documentation. So let's see how we can add on to these steps with help of a few AI tools, and that can enhance our analysis and take it to a next level. So here are a bunch of tools that we can use on top of our analysis. So we have been using Pandas, Plotly, Scikit-learn for our analysis so far. And similar to Pandas, we have Pandas AI, which can be used for normal conversation with our data frames. It can help us in a quick exploratory data analysis in a single prompt. It can even give us descriptive statistics of our whole data frame, and definitely prompt is the key here, but our prompt engineering is the key here, but we can easily use Pandas AI to quickly get a gist of our data frame and perform any grouping aggregate functions. Then we can use LangChain or Hugging Face even for building and trying out a bunch of different models. So we traditionally what we do in modeling when we do hyperparameter tuning, we do cross validation and try out different models and compare them. That we can do with one simple prompt with integrating LangChain or Hugging Face in our existing scripts. Then we also use Gemini, ChatGPT for documentation, summaries, and easy code explanations, especially when we want to deliver our results to a non-technical audience. And whenever we want to build a prototype, we can easily build with AutoML engines like Google H2O.ai. We can simply put our data set into AutoML, which it can try out a model, right model based on the data set, and we define the input variables, output variables, and it will just give us the final results. So it can be even done in less than half a day. So that's how quick it is. We can also use Streamlit Whisper to build interactive dashboards, and these even have voice inputs. So think of delivering your results in an amazing way. Now let's look at an example of a basic predictive modeling uh, project that I think all of us must have done at some point of time in our careers. That is a churn prediction model. So, based on the traditional workflow, what we have been doing so far and how we can parallel improve it with the AI powered tools. So, the data collection steps more or less remains the same. Where we can use we spend a lot of time in general is in cleaning and prepping our data that can be replaced by Pandas AI, and we can do easy exploratory analysis and data cleaning with Pandas AI. When we do feature engineering, we uh, use a bunch of multivariate analysis, correlation analysis, and then we combine different features and go back to cleaning and data, more data prepping sometimes. But we can easily use Gemini or ChatGPT for hypothesis generation or even some ideas on how we can transform our features. We can, instead of training multiple models, we can use LangChain agents or AutoML to tune our models and compare different models and give us the final result based on the most optimized model. Then for deploying or evaluating, we can use ChatGPT to give the results from the model in the most layman terms that can be easily delivered and explained to our non-tech audience. And finally, we can also uh, customize this based on our organization based knowledge using RAG or retrieval augmented generation to give more accuracy and more explainable results from the model. And we can finally use amazing tools like Streamlit or Whisper for voice assisted interpretation or dashboards. So quick examples of a few libraries here or tools that I've mentioned in the past slide. We can use Pandas AI with just a simple prompt of, we can initialize the class, and with one simple prompt like what features correlate most with the churn, it can give us even the box plot if we ask the right prompt. And we don't need to switch from different one tool to another. We just need to have everything in our Jupyter notebook, and like how we have been doing. And with we should also spend some time on prompt engineering. That will take a lot of revisions, but once we have the right prompt with us, it can definitely give us great results. So when we are using LangChain, we can easily ask questions on comparing different models, and we can also use role-based prompt engineering. So instead of just giving a single prompt, we can assign a role to ChatGPT, which is whether it's a system or a user, and give it more context, and then based on the context, we can ask the question. For example, here we can first define the role here in system, and then we can ask the system if that explaining them that they are a data science assistant, and then as a user we can ask the prompt. Now let's look at how we can use RAG and how it is important for our analysis, especially when it is documentation heavy or when we are redoing a project that has a previous documentation ready. So RAG can make our results more accurate and explainable, and it avoids hallucinations that we can get from just using a normal AI tool. And we can give more our project specific or domain specific knowledge to RAG, and even it can help us compare the results from the previous analysis that we have done, maybe churn mitigation project that we have done in the last quarter. It can not only just give us the existing results based on the current knowledge base, but can also help us easily compare the results with previous project, and can quickly show the progress that we have achieved so far. So with a few simple steps, we can add RAG to our existing models. We can initiate document loaders, different PDFs, libraries that we have ready, and create transformers, and we, to break down the documents into chunks so that our model can understand it better. Then we can initialize some text embeddings, vector embeddings to understand the text in a more machine language form using OpenAI and Hugging Face. We can also store the embeddings in vector data stores. Some vector DBs here, examples are Chroma, Wavy8, Pinecone. And then we can use from these vector data stores, we can directly have a LLM model, LangChain or Hugging Face model, and we can use their retrievers and GPT retrievers to get the results, final results, and then prompt based on the LLM model that we prepare. So why RAG matters? Because it improves overall, it creates mini search engines on the existing search, and improves the load, gives us faster results, but not only faster results, but also more accurate and trustworthy results, and gives us a flexibility to also to plug and play between different models. Either it could be any LLM model from OpenAI, etc., or we can add any retriever for better prompt tuning. So I'll end my presentation on this final note that we should be not fearing from AI. We should be using it as a assistant or our co-pilot, and should ask this question that AI wouldn't replace us, but data scientists who know AI, they might. Thank you. Any questions?
So, how do you translate experimentation and user segmentation insights into high-impact marketing strategies at scale, especially in fast-moving environments like YouTube Shorts?
Sorry, can you please repeat your question?
Yeah, so how do you translate experimentation and user segmentation insights into high-impact marketing strategies at scale, especially in fast-moving environments like YouTube Shorts?
Yes. So um, experimentation will give us different lists of uh, how what exactly worked best for us, what not. We can deliver it in different forms. We can either use before after analysis in form of explainable, easily understandable dashboard that can be used easily used by a wider set of audience to understand what factor that we added to our experiment that gave better results as a result of our A/B test. And when it comes to segmentation, the best way I think to translate is either we use generally the our traditional clustering based approaches for user segmentation. We try to give attach more context to it. We generate summaries from each of these segments, highlight the part where how each segment differs from it, and give more organization based context to it, and then propose insights and recommendations on how we can improve the maybe the marketing approach for a particular set of segment. For example, a campaign might be performing better for a set of audience that may not work on a audience. Maybe it work for a audience with a high income group audience, but may not work well for a low income group. And that's how segmentation results can definitely benefit into marketing and marketing the right campaigns.
And set the plot that the next section to and just for the interest of time, we move on to the next presenter.
Nia sound is very low. So okay.